Hey guys, so welcome to Ordering Decimals. The catchphrase, or the thing I really want you to remember today, is zeros go on forever after the decimals. Imagine that, and actually do imagine that. That helps if you sort of pretend like those zeros are there. It's a good little trick. So we'll come back to that. First, we just want to look at decimals. Here we've got let's say a chocolate block, and it's broken into 10 rows of 10. So if I was to take a number like 0.58, I would have a tenth, and actually I would have that tenth, 2 tenths, 3 tenths, 4 tenths, 5 tenths, 5 tenths all together. That is the 0.5. The 0.8 is going to be 8 individual blocks. So I'm just going to do the 8 in a different color, and that's matching up to these colors here. So if I was to need, say, for 0.231 and a 0.1, I'd need to break this square up into 10 also, and take just one little slither. The kind of point here is that this number here, 2, is actually much bigger than the 3, or should I say the 5 in this case, is much bigger than the 8. And that's just to do with place value, and it's the same for big, proper full whole numbers as it is for these decimals. And if you keep that in mind, you probably won't get too far wrong. So if we come back and look at our list here of decimals that need ordering, a mistake would be to say that the 0.231 is the biggest. There are different ways you can do the activity. I'm going to just copy this out again below. So I'm going to take my first one, 0.1 as the smallest, and people might say, well, it's not 0.11, it'll be 0.6. Of course, no, everybody says, wait, hold on, no, of course it was 0.11. Because if I was to have 0.11 on here, it would be 0.1, and then it would be 0.11. So that would be 0.11. And it's obviously a lot smaller than 0.6, which would be coming out all the way to here. I'm just going to undo that one. So not 0.6, not that one. So looking through here, I'm actually going to delete these as I've done them so I don't double up. I'm left with 0.58, 2, 1, 2, 4, 0.6. And I'm really just going to look at the first number. So it's 5, 2, 2, 6. It's going to be one of these two. And since the 2 is the same in both, I can't decide based on the 2. I'm going to decide on the next place value. The next digit in this case is 3 and is 4. Well, what's bigger? It's going to be 0.4 is bigger, so this is the next number in the list. I put that one in there. I know this one by default is going to be the next one, and I'm left with 0.58 and 0.06. And somebody is still going to go, oh, 0.6 is smaller than 0.58. Well, the zeros go on forever. And that means, I could have them like this, and it would go on forever, and it would give me a sign. So I could do that to all of these also, so that they all have the same number of digits, the same number of decimals. And then I can clearly see exactly how small or big each number is. You don't need to do that, but it may help if you're having a real hard time with with decimals. You can add that extra place value in there to help you. So I'm going to take those zeros back out because, like I say, you don't need them, but if you're really stuck, they can help you. So there's the example. Here's the illustration, and at the bottom on the third slide is the task you need to do. So I'll get you to take each one of these and just reorder it. It's on a slide of your own, and once you've done that, please remember to share it with me so I can see it. Thanks very much, guys.